Okay, how you doing? We've got a quick video topic today, and today in Unit 8 our topic is going to be non-linear functions. We're talking about functions that when you graph them don't make a straight line. And you might be wondering how that would be possible. So let me give you an example. Let's say you had a function and it was a very simple function. The equation was just you take x and you square it. So you put a number in and then you square it to get a number out. Okay? So let's make a table of some values here. And let's go ahead and I'm going to plug in, I'm going to start with -3. That might seem like an odd choice, but let's see what happens. When you plug in -3 here, you're going to do -3 squared. Now you know that that means -3 times -3, right? And a negative times a negative comes out to a positive. So notice that even though you plug a negative in, you get a positive out. Interesting. Would that happen if you plugged in -2? Well, let's find out. If you plugged in -2, you'd get -2 squared, and that's -2 times -2. Again, it's a negative times a negative, which should come out positive, and this time it should be 4, right? Because 2 times 2 is 4. And if we plug in -1, you're going to do -1 times -1, which comes out to a positive, and 1 times 1 is 1. Of course, if we plug in 0, 0 squared is just 0 times 0, which is 0. And then, if we plug in a regular positive 1, well, what's 1 squared? 1 times 1, right? And I could keep going here and plug in 2. What's f of 2? Well, f of 2 would be 2 squared. You put a 2 in, you get a 2 squared out. And notice here that I started at 9, and then 4, and then 1, and then 0, and then 1, and then 4. So guess what's going to be next when I plug in my next number? It's probably going to be kind of symmetrical here. If I plug in a +3, I'm going to get 3 squared, which comes out to +9. Isn't that interesting that those numbers kind of are a mirror image of each other? Huh. Well, let's take a look at what the graph of that would look like. So I made a nicer, neater table here of those values, but watch what happens when we graph those points. Okay? And I'm just going to put dots on the graph. If you go to, let's start at 0, 0, because that's an easy one to graph. Okay? Boom. We put a dot at 0, 0. Okay? Easy enough. And then 1, 1 is also pretty easy to graph, so I'll put a dot right there. And normally at this point, you would be thinking, oh, it's going to be a line that goes like this, right? Not so much. Watch what happens next. When I do 2, 4, my next dot is going to go over 2, and then up 1, 2, 3, 4. It's not quite linear with that line that we thought was going to go this way. Now it's kind of crooked. Interesting. And then when we do 3, 9, that's way up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we put a little dot way up there. And we can see that this is a nonlinear graph. The question is, how do we connect the dots on this? Well, wait, before we connect the dots, we still need to do these other ones. So notice it's going to be a mirror image. -1, 1 is going to be up here, right? Because you go backwards 1, up 1. And then -2, 4, right? This one is going to be backwards 2 and then up 4. Oh, it's a mirror image of the right side of the graph, but now it's just on the left side. -3, 9 is all the way over here. Okay, the question now is, how do I actually connect the dots? And the key to nonlinear graphs is when it's an x squared, it's going to have a curved shape. We're not going to make like rigid straight lines here, and then straight lines here, and then straight lines here. Okay, we're going to try to take this and make it a nice curve that kind of curves through these points. That was not the best drawing ever, but you get the idea. It's kind of a U shape, and whenever there's an x squared in your function, it's going to make kind of a U shape, and there's a word for that kind of a shape. In math, we call this a Parabola. That's called a parabola. Okay? A parabola is the name of that U-shaped graph that happens whenever your function has an exponent of 2 in it. Okay? So, nonlinear graphs can sometimes happen when you have exponents involved in your functions. They also can happen in other situations, but just you want to know that sometimes they come out curvy instead of straight lines. Okay, that's really it for today. So what I want you to do, instead of doing a practice problem, is I just want you to see if you can come up with a function equation that you think might have a nonlinear graph as well. See if you can make up an equation that when you graph it would come out curvy or not straight. All right, that's it for today. See you next time.